Over there for me. Okay, so we're going to go ahead and start. So some of the topics we're going to go over today are going to be, we're going to review any lab questions, and then we'll go over moles. So if y'all want to send any questions to us in a chat, or if you want to just voice your question, and Miss Nicole and I will go over, we'll try to answer them. So anybody?
Questions about what? Sorry.
About the labs. Any of the lab questions?
I don't have any questions about the labs, but when we get to moles, I do have questions.
Okay.
Ooh.
You have something, Chris?
Oh, sorry. I forgot I'm not mute.
Okay. Nicole, is there anything that you've seen like with the labs that you want to share here? I can even do the board if you want to, if we need to write anything out.
Let me go through all my notes.
Okay.
Well, there's a lot that still need to be turned in, but from the majority of people have been doing pretty well. The homework, this last homework was probably the worst graded assignment across the board.
I completely forgot about it.
Well, that didn't help with it being the worst graded across the board. But you can still do it and turn it in. Just you can fill it out and then take a picture of it and email it to me.
Okay.
I think people were going too fast, and they were like doing the bottom row on the top row, and then they redid the next row underneath it. So like they had doubles of the same run.
Mm-hmm.
Or they were putting the subscript in the spot where the oh, what is it? I can't even think right now. What's the top number?
Here, let me pull up a picture. Let me look at
The charge. They were putting so they weren't, so it starts with the charge, but it has to become the subscript. But they were putting it as a charge again. And then the parentheses, either using them when they didn't need to, and then not using them when they needed to. A lot of them didn't put mono on the compound names.
Where are you?
And then, so a lot of little mistakes, but a lot of mistakes with the crisscross method and the naming the compounds.
Okay, so here I have these. I'm trying to figure out how to, Josh isn't here. He usually helps me to do the whiteboard.
Probably shouldn't do too many of them because some of them still haven't turned them in. Unless we want to do like different ones, like off completely. We don't want to give the answers.
Well, I gave everybody the answers to number 5.
Well, you did do that.
Creations out of that big box because I'm trying to find some stuff out of it.
Okay, there you go. Thank you.
Okay. So, Benaya, if you wanted to resubmit your crisscross method, oh wait, I have it. I'm gonna email you later, Benaya.
Okay. Not in this at all.
Okay, so I don't want to like make up a formula that's not like an actual formula.
Well, what we did last one is we worked out that first whole row. So we did like Na plus
right.
plus Cl negative, CO3 -2,
Okay.
Na plus. So we can go through that again if you would like.
Okay, yes. So let's do oh wait, am I the only one that do you have it with you?
Yes, I'm trying to, I don't know how I share it. I just closed everything.
Yeah. I mean, we could just write it too.
Okay, so the first one's gonna be NA plus and CL negative or
That one
CL
is easy.
minus.
That one, no, I don't think anybody got that one wrong.
Right, but we're gonna go across.
Oh,
We'll do
okay.
that whole row because that's what we did during the last Zoom. We did that whole row.
Okay.
So we'll just go through NA plus, CL negative, and if we want to show how that.
Yeah. Trying to think, because the text box won't put the little twos. We don't have any numbers on that one, so. Are you gonna pull up that thing or are we gonna use this one?
I'm not seeing anything. Oh, you can use this because I can't pull it up. I don't know until Josh gets here.
It was NA. And then,
So it's NA plus and then it's CL negative. Okay, here, I just moved it over here to the screen so then I can see over here. Okay, perfect. So NA plus and then it's CL.
oops, CL. Oh, that was another one too. Some people thought that was an I. And somehow it became iodine.
Oh, okay. Here, how do I share this screen?
Now you can share, Ange.
Okay, so how do I share it, Josh? What do? I don't remember.
Hit the down at the bottom. There's that green box that says share. Hit that, and it'll pop up the numbers on the screen.
Okay,
and you
which
select
one?
which screen you want to share.
Okay, there we go. Okay, do y'all see that?
It's still loading. Yes.
Yes,
Okay, so
I
then
can
we
see it.
Okay, perfect. So we can annotate in that so we can write in there. So do you want to lead it out, Nicole, or you want me to?
Sure,
It's whichever.
I can.
Okay.
Okay. We can just write in it with the
Yes. Yeah, go to annotate. And then on the sidebar, you can draw, or I think last time we could type
I
if you
don't
do the T.
I
If you
don't
do
have a
text.
sidebar.
Okay. Okay, you walk it through and I'll write it in.
All right. So when you're doing these, you're going to start with a positive. And so it's going to be NA. And always lowercase second letter.
Yes.
And then you're going to put CL. And that's it. It's hard to do on here because I can't like use a whiteboard.
Was it easier on the whiteboard?
Well, no, not this whiteboard, like an actual whiteboard.
Yeah, so you can show where you're crossing. Yeah.
Yeah. You guys understand the crisscross method, right? Like crisscross.
I
So the
kind of understand it.
okay.
Let me see if I can write. Okay, if I can write. Okay, so you have NA plus, man, and then you have
I have whiteboards here.
CL negative. And so here, we'll do this next one. So NA, you have NA, man, I don't like this. I need an actual pen. NA plus, and then you have CO3 negative 2. And so this one, because you have a plus right here, you know that that plus just means that it's a 1. So that means we have a 1 here, but we don't have to write it. So,
Oh no, I'm agreeing with you.
okay. So then what we're needing to do is we're needing to balance these out. And so how you balance it out is this would actually have parentheses around it because it's giving a -2 charge to CO3. And so what you're needing to do is you have a positive here and you have a negative here, and And so to crisscross, this is going to come here and this would become a 2. And this comes over here and it would be a 1, but we don't need to put it. So then it ends up becoming in a 2.
Just me.
Yeah. Na2, and then it would be here. Let me see if I can write it out. It would end up being Na2 and then parentheses.
You don't need the parentheses for this one because there's nothing added.
Oh, okay, yeah, if there was then. So we can go CO2, CO3, CO3.
But those
so-
numbers would be at the bottom and not the top anymore.
So, because they've crossed out. So that's why it's called crisscross, because we're just crossing out whatever is the charge. So the charges, so this -2 or this negative, or this -2 or this -3, or this right here negative, that's going to be what crosses out with whatever else is, whatever charge the other one is crossing. Does that make sense? Not at all?
Kind of.
Okay, let's do the next one.
I have a question. Whenever you're crossing them, do you bring it down to the bottom? The
Yes,
numbers?
you take it.
Okay.
Correct.
Does that make
Yeah.
sense now?
Yeah,
You,
I was
Okay.
putting them at the top.
yeah, do you want to
Okay.
read yours?
Yes, ma'am.
Okay.
Okay, so this is going to be this next one. Who wants to volunteer to say what that is? Anybody? Or we'll walk through this first one again. Nicole and I will go through it again. So this one, you see it has a negative right here and it has a positive right here. So it doesn't have a number, so it means that it's a 1. So then what we're going to do is you would crisscross them again, but you don't have to exchange anything. They both cancel out. Because remember, we're trying to 0 to balance them out. So this one would just be NaOH is what that one would be. Does that make sense? Right there?
Yes-ish.
Yes, ma'am.
Okay, we're gonna do the next one. It's okay, we'll keep going through this. And then we'll do the second line and. Okay, so then this one right here, this would be better written out too. So let me see if I can switch over to pencil. So let me make my pencil a little bit wider. Okay, so then this one right here, what we would do is you're gonna have NA, and it just has a plus. So that plus means what? It has 1, correct? And then you have SO, and then a 4 on the bottom. But if it helps you out to not get you confused, you can put a parentheses because you know that that 4 is connected in there. It's not a charge. And then up here on top for that whole compound is a -2 charge. So it's Na plus because you're grabbing it from here. And then it's SO4 with a -2 charge. Okay. So then what we do to balance it is this, we're going to have the -2 come down over here to the Na. So you're going to end up with Na2. And you're going to end up, you're going to do you can just do SO4. O4. And that balances it out because they crisscrossed.
So basically, whenever you crisscross, you just take the one from the right's number and put it with the one from the left.
Yes, and it becomes a subscript. So these little numbers down here are called subscripts, the ones down here.
Oh, and so it also goes on the bottom instead of on the top,
Correct.
right? Okay.
Correct. So the top are the charges. So these are the charges up here on top, and the bottoms are the subscripts. So
Okay.
this is how you would balance that out. So you bring the 2 down, and so this ends up here. Let me go to typing again. So then this one right here would end up being NA, and then it would be Na2. That 2, again, like Ms. Nicole said, would be little. It would be
Okay.
written little.
A little and down to the
Almost
bottom
like
of the
one of
right.
these. Yeah, it would
Yeah.
be like this. It would, you know how
Okay.
this says SO4?
Yeah.
This 2 would be down here. So it'd be Na2, and then it would be SO4, and that 4 would be down there too. Sorry, O4. And so they crossed out because the 2 came down and it became Na2, and the 1 crossed over and it became SO4 because it didn't change anything.
Okay.
So then that balances it out. So we'll do this next one, or does someone want to try to do this next one? And I can,
I guess I can.
okay, I will write it out if you want to. So tell me what you would do.
I guess I would start with the Na plus,
Okay.
and then inside of parentheses, I would do PO, and then a little 4 on the bottom, and then a -3 on the top.
Okay. That's a 3.
Okay.
There we go. It's a 3. Okay, so if we have a 3, so then what do you do?
Uh-huh.
How do you, if we're going to crisscross, then
Basically draw a line from the right to the left, and then from the left to right. No?
and so then what comes here?
And then down there, it would be would it be just a 2 or 3?
Well, remember you're messing. You're
With the
going to be
negative.
using. Yes, you're using the charge. So what charge would come down then to balance this out?
3?
Yes,
Mhm.
correct. Good
Okay.
job. So it would be Na3, and then it would be what happens with this positive charge.
It'd be no. Yeah. No, PO4.
Mm-hmm. Correct. Good job. Because you just take a
Yeah.
1 over and you don't have to do anything else.
All right.
So here, let me change over to typing mode because I'm better with that. And so then this one would be NA 3. And that would be the little 3, would be little by the bottom, okay? And then it would
Okay.
be PO4, and that would be a subscript as well. So the 3 and the 4s would be subscripts. They would be down below, okay?
Okay.
And we don't have to put a charge there on the PO4 because it was just a 1 that we brought. Okay?
Okay. All
So
right.
now let's try to find one that's a little bit harder. We'll do
We
one.
need to go down because
So this one?
yeah, just about everyone missed these ones. The
Okay.
CA2 2 plus and CO3 -2, -2. So the
Okay.
second one over.
This one right here?
Mm-hmm.
Okay.
It was one of the simplifying ones.
Okay, so then we're gonna start with, oh, let me put my pen. There's our pen. So we're gonna go C, A, and then we've got our +2
Mm-hmm.
up on top, and then we're gonna do in parentheses, we're gonna go ahead and put in parentheses. So we're gonna go CO3, and then parentheses because the charge is for the whole CO3, and that's going to be a -2 charge. So these charges, we would bring this down, okay, for crisscross. So this would come down over here, and this would come down over here, but it's 2 and 2. So if you have a +2 and a -2, that does what?
0 it out.
It's 0.
Yeah.
So we don't have to do anything at all. So we
you
can
just
actually,
put CA
Correct.
in the bottom left.
Mm.
Mm-hmm.
yes. So then you would end up doing CA, and then you would do CO3 because the 2 charges canceled out.
Oh, okay.
Do y'all see it? Because this 2 up here, this -2 charge and this +2 charge, when you brought them down, they would cancel out. So we don't have to show that. We know that if we just write CA, CO3, that they canceled each other out.
Okay. Yeah, that makes sense.
Okay, we can do another one. Let's do, yeah, how about that one? Is this PO4 one, CA2, PO4? What about that one, Nicole?
Not that one. Not that one. The SO4 and the CA.
This one?
Yeah.
Okay, so let me do a writing again. So we'll write here. This one, right? Okay, so we're gonna do again CA2 plus. And then we're gonna do, I like putting parentheses so that it reminds us that it's the whole compound that's being charged. So we don't want to mix up that other number. That was a good 4. Okay. Okay, so you have a positive 2 charge over here, and you have a negative 2 charge over here, correct?
Uh-huh.
So
Yes.
what do you think's gonna happen? Anybody?
Positive 2,
They're gonna-
You have
negative 2. Oh, zero it out.
They're zeroed out. So then what do you think it's gonna look like?
It's just gonna be CA on the bottom left
Okay,
corner.
okay. And then what else? S.
SO4 in parentheses.
Well, we can just do SO4 because I mean we could do parentheses, but I just use the parentheses up there just because of the charges, so that kind of lets us know that the charges are all on here. So I mean, you're not going to get docked if you do parentheses. You'll be fine doing that. But really, when we're trying to take it down it to, I guess, the smallest, excuse me, possible, you would just do that.
Okay.
But do y'all see how they crossed out? Because you have a positive charge here, your Ca2 plus, and you have your negative charge here, 2 minus. And again, all you're doing is you're gonna, let me go to my pencil again. And what you're gonna do is you're gonna go down over here, you take that negative 2 and you take your positive 2. So negative 2 plus positive 2 would end up being 0, right?
Yep.
So that's how we get our CaSO4.
It's like algebra. When you're simplifying it, you want it to be in the simplest form as possible. So if you had 2 and 2, it's really still just 1 and 1, because you could still double it and it'd be 2 and 2. You could do it again, it'd be 3 and 3, but you want it in the simplest form.
Okay. So it's like 2 plus negative 2. You just
Correct. Yeah. So I think what Nicole was saying is people were still writing a 2 right here underneath this, and that doesn't need to be there because we know that they crossed out and they zeroed out. So then we don't need that. All we need is the CaSO4. That would be the simplest form that we could write it as.
Okay.
I know I did that.
Okay. So here, we'll erase that, clear the drawings, and then we'll do one of these magnesium ones. So which magnesium, Nicole?
Let's do the PO4.
Okay, so PO4 3 minus. Okay, so it's gonna be, does anybody want to try this? Or I can do it. We'll do this one. So Mg, and this is a +2. And then I'm gonna do my parentheses again, just because I like to show that it's what, PO4, because I can't see it on my screen.
Yes.
PO4.
With a -3 charge.
Okay, and then a -3. Okay, so this one's going to be a little bit more involved. Here. Okay, I'm going to move it up just so that I can write. Nope, I'm not going to move it up. Okay, so then what we're going to do is you're going to have to crisscross it. So you're going to have to bring the 3 down and you're going to have to bring this 2 down. So if you do that, you're going to go Mg.
1,
Nope. What are you bringing down?
a 3.
What is this number? Yep. So it's going to be a 3. And then what are you bringing down over here? Remember, we have it in parentheses, so it's going to be PO4
wow.
parentheses. And what are you bringing down?
2.
2.
Okay.
So our number is our formula, our compound will be Mg2. And then we're going to have our parentheses and we're going to be PO4.
MG3.
Oh, sorry, 3. It is 3.
Parentheses.
Sorry. MD3. And then our parentheses and it's going to be
PO4 parentheses 2, right?
Yes,
Yes.
perfect. Good job.
Okay.
Yes.
And
And these
where
are
does
going to
the
be
2 go?
subscripts.
Okay.
Oh,
Where does
Nicole asked it.
Yeah, where does
What?
the 2 go?
The 2? It goes
Yeah.
on the top, right? If
No,
it was
bottom,
no bottom,
bottom,
but the
bottom.
four's on the bottom.
No,
Shows
because
the-
remember, this is in parentheses, okay? And
Okay.
the
Then
reason
why
it's,
is your 2 on the top?
it's on the top when, because of where I crossed it. I just brought them down.
Okay.
So they're not supposed to be on top. Sorry. It is supposed to
Oh,
be on
so
the
they're
bottom.
okay. So the MG3 would be on the 3 would be on the bottom of that too.
Yes.
Oh,
Yes, over here.
okay.
It would be right here on the bottom.
Every time
Oh.
you do the crisscross
then-
method, you're going from top to bottom. Just remember top to bottom if that helps. Always bring it down.
Okay. From top to bottom.
And yes, on this one, you need the parentheses because if you don't have the parentheses, all it's showing is that the O4 has the -3 charge, but the PO4, well, I guess down here would be the 2 at the bottom. But if you don't have the parentheses, it's only showing that it goes to the last one. We want to show that both the PO has it, so you have to put it in parentheses. If that makes sense.
Are we good? Or we need another one?
Trying to think of like an easy way to explain it. I don't know.
Can I just ask a quick question?
Yes, ma'am.
So with the last one, we did the MG3 with the parentheses PO4 too. So anytime it has a subscript and a charge.
A charge?
want the
Mhm.
paren-
Yes,
Okay,
Mhm.
yes, because you're giving it to the entire compound. So you're
Yes.
giving it to the PO4.
thank you.
Yeah.
2 capitals.
Yeah, so this would actually be like that.
Just the
Mhm.
Because then it's telling us that it's giving it to the entire chart, to the entire compound. So then you just are going to move this over. So the 3 will come down and then the plus would come down. Yeah. Okay. So does that make better sense?
Sorry, I have another questions.
Yes. No, go for it. We want this.
When you have positive and
Mhm.
negative and you're doing the crisscross method, do they stay positive when they crisscross? And do they stay negative? Or does that
No, it
matter?
loses. It doesn't matter. You don't add it. It doesn't follow.
Okay,
So it only follows as the charges up on top, but when they come to subscripts, there's no positive or negative.
okay, thank you.
Okay, let me see. Okay, anything else?
No. I think when naming the compounds, there was a time when you said like we didn't have to use monos at things, so I think they took that for this part and you meant it for something else. Because none of them, well, I guess not none of them. A lot of them didn't use mono when naming the compounds.
Oh, on the other,
Yeah.
okay, so here, let me go back.
And then getting the L confused with an I. So we just need to clarify that if it's not a capital, it is a lowercase. And the lowercase goes to the the letter before it.
Oh, okay.
And I'm trying to think, look at this. Only notes.
Okay, there. Do y'all see that?
Yes.
Okay, so do you want to do any one of these?
The top one's easy. Does anyone want to tell me what C is?
Uh, carbon,
Yes.
let's see, and then O is oxygen. So would that be carbon oxide?
Nope.
So what, remember we did the like, bi meant two, mono meant one. So mono is one and bi is two, or we did di is two, and
Yeah.
then tri, and then, you have, what is it? Penta, and then hexa. So, but one means mono, or MON would be the beginning. So for CO, it would be carbon monoxide, because you're telling us that there's only one there.
Okay.
But
So
we
this
don't
is
use
where,
that mono on the first one, just on the second portion of it.
Okay.
It's confusing, but yes.
so you would just do carbon monoxide is what it would be. And yes, it is deadly. So, what about this one, the N2O5? So, let me see if I pull, that's no.
Yeah, that tricked a few people.
Yeah, is that the, no, PowerPoint, no. Is this the one? Here, let me go through this and see. So remember we did the, where was it? Oh, this, okay. Y'all remember this? So mono is one, di is two, tri is three, tetra, penta, hexa, hepta, octa, nona, deca. So you only use these prefixes for covalent compounds, not the ionic. And so, yeah, this is where it got a little complicated.
Yeah.
So, okay, so let's jump back over here and then we can come back. Okay, so if you have into O5, how would we call that?
Sorry, what was the question again?
What would we call, how would we name the compound for into O5?
5's penta, right? Or
Yes.
Okay. Would you do the di on the nitrogen?
Yes.
No.
Are you sure?
Yes, you're right. You're right. Correct.
You're like, oh no, did I grade everybody wrong?
No, you're correct.
Yes, so yes, you put that first.
Okay, so would it be dinitrogen penta? Wait,
Yeah.
dinitrogen pentaoxide?
Yes.
Okay.
Okay, so how about this one? BCl.
3.
BCl3, yeah.
B's boron, correct.
Yes.
Yes.
Okay, so would that be boron trichloride?
Yes.
Not try. Hold on, did you say try? Yes, try.
Yeah.
Yes.
Yes, you are correct.
This
Okay,
was
Okay.
I did
better.
understand this one.
Yeah, it was. I don't a lot. No, I think you did okay.
Okay.
I graded a lot of papers. I don't remember.
Okay, let's do this one. Cl2O.
Chlorine? Is that the first, the Cl?
Mm-hmm.
Okay. Chlorine to. Oh, where, my mouth? What the? What the? Sorry, sorry. Is O oxygen?
Yes, sir.
Okay.
Are you there?
Yeah.
Okay. Nicole, you want to lead it out?
Okay, so it's going to be dichlorine monoxide. You got to put the di first because it's chlorine, or I mean, it's 2 and then chlorine, and then there's 1 oxygen, so monoxide.
Oh, okay.
Does that make sense, or are you still confused?
Yes, but there's a chance I won't remember that. Like it makes sense right now.
Mhm, mhm, mhm. That cheat sheet, if you have it with your papers from her slide that has the mono, di, tri, when you're doing this worksheet, that will be helpful when you're naming compounds. This one.
Okay.
Remember, it's only for the covalent ones, not ionic.
Okay.
I have a question on that.
Yes, sir.
Did you say this, or was it just something I made up in my head? But that not always they have the mono if it's a singular, uh,
Correct.
whatever. Okay.
No, you're right. It doesn't always have to have that. It can be just oxide. So
Okay.
it just, yeah.
Yeah.
So like if you had CaO, it would just be calcium oxide. Ca and then O would just be calcium oxide.
Yeah.
I guess you could do monoxide, but if you just did oxide, you could do that as well. They both mean that there's only one.
Okay.
So
Like the rest of the English language.
I know.
Doesn't make any sense. It's just how it
So
is.
yeah, so here's similar to that one. See, it had Cl2, so dichlorine, and then this one with that O7 would be heptaoxide. And then, okay. I'm gonna go ahead and come back over here. Okay, so do y'all want to do any more from here? Okay.
What?
No. You do want to do more?
No, I said what? I was talking to my
Do y'all
brother.
want? Oh, okay.
Uh,
Okay. Nicole, is there anything else?
No, I think that's it. Most of the other labs that have come in have been pretty well. People just forget to do sections, so it's not that they're getting anything wrong. They're just forgetting to do parts.
like forgetting to write chemistry.
Yep.
Okay. So hopefully this is more helpful. Again, go back to your PowerPoint. Go back to if you kept your paper. I can probably email these out to you guys as well. So okay, let me see how I can go back and share the screen, my other screen. There we are. Okay, share. And let me change out to the screen. Okay, perfect. Okay, so topics. So is there any more lab questions?
I have
Okay.
a question on the lab.
Yes, sir.
What if at the data table we only had 4 things recorded?
Then you fill out what you have.
More information. Okay.
Yeah.
Okay.
Yeah, you don't have, if you didn't get all 7 or all 8 that, you know, like if it didn't work, then yeah, just do what you have, just like she said.
Okay.
Any other lab questions? Okay,
I
so then
have-
we're gonna go, yes, go ahead.
Okay. At the back of the thing, what is the paper with like the peanut butter and jelly?
Okay, so that is, so we're actually going to go over that with moles. But what it is what is your limiting compound or your limiting element, meaning which one is going to run out first that's going to only allow you to do so much of the allow the reaction to go so far.
Okay.
So here I'm about to have an example. I think I have it here. Let's see if I can come over here. So it's actually this right here. So like the limiting factor on here is going to be our eggs.
Uh-huh.
because you need 2 eggs, but actually, hold on, is this the right one? Yeah, so the eggs is for this we're doing the eggs. So you have 5 eggs. So how many of the how many dozens or how many cookies can you actually make? Well, since you have 5 eggs, you can actually make, how many dozen? You can actually make 2.5 dozen. So this one is dealing with moles. But anyway, the eggs in this case would be our limiting factor. For our lab, the limiting factor, well, it ended up turning into something different. But I think it was supposed to be the vinegar. No, was it Nicole? It was on there. Is it the vinegar or is it the baking soda?
I don't remember. Let me see. Find it.
Here, let me open that lab.
Yeah. I didn't put anything in order.
Let me find it. Unit 6 lab. Okay, there it is. Okay. The baking soda becomes the limiting factor because it gets consumed. So as far as the baking soda, as fast as the baking soda gets consumed, that's when the reaction stops. So when the amount of baking soda that we had in there, which was 1 teaspoon, well, that was what we originally started, that would be our limiting factor. Because however much we had of that, so as we added more, the reaction would theoretically go longer. But we kept that as our it wasn't a variable, it was our one of our constants, where we kept the baking soda as 1 teaspoon throughout everything. The only thing we changed was the amount of vinegar.
Okay.
Does that make sense?
Yep.
So it limited it, so it's limiting because it's what the amount that you have is as far as it will go. So it's kind of like, okay, you put how many miles per gallon can you get in your car? Well, you're limited because if you only put $5 of gas in, how far can you go, right? So you're limited on how far you can go. So based on, because you only put $5 of gas in there. So that's what it's doing in this lab, is we can only allow the combustion or the reaction to happen until the baking soda's been used up in the reaction. So it's limiting to 1 teaspoon. Now by the end of the lab, it was limited to probably a cup. I don't know how much y'all mix together, but
Oh, goodness.
Yep. Our limiting factor was definitely the cups.
so, okay. Is there any other questions with that one? Okay. Okay. So then let's go ahead and come over here. Let me see. Do I have questions? Sorry, I hadn't been paying attention to that. Okay, so moles. So what is a mole? So first let's go back to our periodic table. So everyone was given a periodic table, and remember, your periodic table is kind of like your map. It's your guide. It gives you a lot of information. And so how to read each one of these elements is, remember, you've got your atomic number, you have your symbol, which is what we write in our, when we're writing either the element or the compounds, and then the name of what it is, and then your atomic mass. And so, okay, so, and remember the atomic number, it equals the protons in the element. So this tells us how many protons there are, okay? So if there's that many protons in a neutral atom, the atomic number also equals the number of electrons. So the electrons. All the atoms of the same element have the same number of protons, and the smaller of the two numbers in the periodic table square always is a whole number. So what we would write like as a, oh, the atomic number 6, but then when we do our atomic mass, we round. And so for this one, what would the atomic mass of carbon be? Anybody?
12.
Correct. It would be 12 because you just round it. So you don't have to write 12.011. Okay. It would just be 1. I mean, just 12. So atomic mass of carbon is 12. Well, here I'm going to share the screen over here. Let me put that down. Okay. So look over here. So can you tell me what would be the atomic mass of sodium, which is Na? It's in group 1.
23. Oh,
Correct. Yep, correct. You would round up. It would be 23. Okay. Can someone tell me what would be the atomic mass of oxygen?
16.
Correct. What is the atomic mass of, let's see, krypton? Kr.
83.7. No, 0.8.
Yeah, or you could round and just do 84 if you wanted to. So, one more. What about nickel? Ni. It's going to be in your transition metals. Remember, transition metals are here.
$59.
Correct. Yep. So you're always going to look at these numbers down here. These are going to tell you what the atomic mass is, okay? There's a fancy formula that we can do, but if you have your periodic table, it's going to give you your answer to your atomic mass, okay? So this right here is, again, it's your map. It's your map showing you what a lot of information is. Okay, so we're going to come back over here. Okay, so what is molar mass of an atom? So the molar mass, like what we talked about, was your protons. You know, you have for carbon, we know we have 6 protons. We know we have 6 neutrons. So 6 plus 6 is 12. That gives us the atomic mass. Or we can look on the periodic table and we see that carbon has a 12 as its atomic mass, right? Just like we saw a while ago. It's right here. So, okay, so what is a mole? It's not the animal. Womp womp. A mole, it's just a number. So it's just like how you say 1 dozen is 12. 1 mole, it equals Avogadro's number. So it's this number right here, which again, it's a fancy number, but we're just going to say, okay, we know that 1 mole of something is that. So like for instance, 1 mole of apples, it equals that big number there, but it's basically that many apples. 2 moles of apples would actually be 2 of that number of apples. But then here, let's relate it to our actual carbon. 1 mole of carbon would be, it would just be Avogadro's numbers of carbon. And if we did 5 moles of carbon, we would actually multiply 5 times Avogadro's numbers to give us the atoms of carbon. So that's how we would get a mole. But again, that's where we come here into the proportions. Let's see.
So is a mole just a really big number?
It is. It's a really big number. So a lot of times when we're writing it, we're just going to write mole.
Okay.
For us. For us being at high school chemistry, we're just gonna do a mole. But just if you go on, you're gonna know that you're gonna need to know that 1 mole equals 6.022 times 10 to the 23rd power. But for us, we're just gonna call 1 mole. Okay, so a mole is, know that a mole does have a this is what it means. So
Okay.
go ahead.
I was
Oh.
just saying okay.
Oh, okay, I didn't know you had a question. Okay, so then this is going back again about ratios. So again, this is like Miss Nicole said earlier, math. Math is coming into chemistry. So what you're going to do here is, again, our limiting factor is our 5 eggs. We have 5 eggs, and when we run out of eggs, we can't make more of this. Okay, so our 5 eggs, and then this is our recipe that we have, and we're going to use this many eggs. So if we have this many eggs, we're going to write it already here. If we know that it takes 2 eggs to make 5 dozen, then we're going to write, okay, the ratio is 5 dozen takes 2 eggs. And you're going to put it like this because you're going to want to cross out your eggs so that you can figure out how many dozen. Okay. So then what you do is you're going to do 5 times 5 is 25. Divide it by 2. And that means you can make 12.5 dozen cookies. Does that make sense?
Yep.
Okay, so in example, say we had moles here. We would have 5 moles, we would have 2 moles. These would cross out. So you're always trying to cross them out because you don't want to carry that over, because we're trying to figure out either pounds, liters, or whatever. In this case, we're trying to figure out dozen, okay? So like say we only had 4 eggs. What would we do? How many cookies could you make? You would have 4 here, 5 there. 4 times 5 is 20. 20 divided by 2 is 10. So you can make 10 dozen cookies. So I know, what does cookies have to do with chemistry, but this is just kind of telling us, it's showing, it's limiting you. We're limited by something, and all the time, like in any chemical reaction, it's always limited. Like a reaction, I'm trying to think. Well, even just going back to our lab, we were limited by the baking soda we had there. Once the baking soda ran out, we could not do anything. Like, I mean, we should have done this. We should have tried pouring vinegar back into a bottle that had already been used up to see what would happen. What would really happen, or what would do y'all think would happen if we poured vinegar into something that was already done, like one of our used up cups?
We did that, and it
Oh, good, y'all did it.
already fizzed. It just didn't work in general.
So it fizzed a little bit?
Yeah.
Okay. So it gave a little bit of reaction, but it didn't give like your initial combustion or your reaction that you got the first time. Is that correct?
Yep.
Okay, so that was our limiting factor. So what would have been optimal would have been that it didn't do anything at all. But but possibly there could have been a residue of the baking soda or something there. So okay, so let's go to the next thing. So mass relationship between substances. Let's go over here to this one. Okay, so this is conversion as well. So again, this is going to be making something. So this is, you have 2 milligrams, or sorry, milligrams. I'm bringing work back. You have 2 of magnesium plus 2 oxygen with a subscript 2. And so if you combine that together, you're going to end up getting 2 MgO. So what would be the mole ratio of the magnesium to the magnesium oxide? So you have, it's a 2 to 2. Why? Because you're going to write out how many moles of magnesium do you have? You have 2 right here. And how many of the MgO do you have? You have 2 right here. So it goes 2 moles of magnesium over 2 moles of magnesium oxide. So what would be the mole ratio of oxygen to magnesium? So where is our oxygen? Right here, we have a 1. Remember, it's the unseen 1. It's like the known 1. If it doesn't have to be there, but we know that it's a 1. So you're going to have 1 mole of O2, and you're going to have how many moles of magnesium? You're going to have 2. So it's going to be a 1/2. So it'll be 1 mole of O2, 2 moles of magnesium. Do y'all see that? Okay. So let's practice this. So here, this is going to be 5N. This is a subscript 2. This is a 2NH subscript 3 into F4. These are all subscripts, and then 6HF. So what is the mole ratio of NH3? Let me see if I can write. Annotate. Okay. So it's asking for NH3, so it's going to be this one right here. And your F2, right? F2. Where is my F2? Oh, I wrote this wrong. Did I write this wrong? 2NH3 into F4, 6HF, 5. Okay, this is supposed to be 5F2. So this is supposed to actually be a F. Sorry. So this is an F right here. Okay, so what would the ratio be? So NH3, what's the number that we see here? So NH3 is a 2. So we have a 2. And then our F, what's the number that's in front of the F? What's that number? Anybody?
5.
Yes, thank you. So our ratio is going to be 2 to 5. So you're just saying basically what it is. You have 2 of your NH3s, you have 5 of your F2s. So to write it as a ratio conversion factor, because we want to convert it, because this is prepping us to do formulas. So if we want to do that, then how we would write this is we would write that there are 2 moles, MOL, of NH3. H3, and then it's going to be over, because remember, a ratio means it's it's going to be a percentage. So 2, and then it's going to be 5 moles of F2, and it would be down here like that. So that would be this. So what is the mole ratio of HF, which is right here, to into F4? Does anybody want to try that? What would the ratio be? So what is HF? How many HFs do we have? We have 6.
6 to
Okay.
1.
6 to 1, correct. Because we don't have a number here, so we know that there's just one of this into F4. So it would be 6 to 1. So how would we write that if we wanted to do it as a conversion factor? 6 moles of into F4 over 1, which we wouldn't even have to write 1. We would just write, I guess we would, because we'd have to know that it would just be that, in 1 mole of, oh, I wrote this wrong. Sorry, guys, that's wrong. 6 moles of HF. Nobody even caught me. Of into F4. Okay, so this is how you would write it whenever you were wanting to convert it, to get ready to do like if they said, okay, we had 28, how many moles of HF would we have in 5 liters, and this is how we would prep to do that. So let me go off of this. I know this is a totally different topic from what we didn't really cover it, but it's still part of Unit 6. So that's why I'm kind of going over it now. because it's part of Unit 6, and when we come back, we're gonna kind of go over it some more, but I thought, okay, let me use this time to kind of introduce it a little bit. So you don't have to know everything about it right now, but just know that we are gonna get into this a little more. Oh, I need to let me clean my thing, sorry. Okay, and it is already, it's 8:43. Okay, I gotta go. Y'all have to go too. But here's some formulas. So again, this will probably be something that I will add on. So you're gonna have a lot of cheat sheets that I'm gonna I'll try to overbreak. What I'm gonna do is I'll probably try to make these smaller so that you don't end up with a whole bunch of sheets. And I'll try to put them onto at least like another front and back, like I did with your periodic table, so that you can have these formulas accessible. Okay, so moles. We will, like I said, this is introduction. We will go more into it. Isaiah, did you have a question? I'll try to answer your question before we go. Or I can ask you, I can do it later, whichever.
Yeah, it was just about moles to grams.
Okay, so that's going to be this one right here. If you have the grams that you know. So it's meaning that like you were given your grams or that you're trying to convert it to grams.
Both.
Okay. Okay, yeah, that's gonna be a little more. So what we'll do is I'll go over that with you in a little bit. But I don't want to keep people over and above the time. So, but this is introduction. So y'all got a little heads up on what we're gonna be doing. I want to encourage y'all to bring your notes on Monday. Bring your periodic table to be ready, because it is going to be questions over the last 6 units. And so it's kind of like we're taking a final together, but we're playing it as a game. So be ready to win for your team, or win as a team, right? Because we work together. So, okay, anything else before we go? Okay, guys, thank y'all so much. And I will see y'all on Monday. And like I said, we sent out for people who are missing things, or if you want to correct things, be sure to send it to Nicole and myself by midnight. I went ahead and did midnight. Nicole, I hope that's okay.
Yeah, on Saturday.
Yeah, midnight Saturday, which is the 22nd.
That's fine.
Because
Because on Sunday I'll print progress reports to bring on Monday.
so you can take a picture and you can send it, or you can scan it, however you want to do that. Okay?
Okay.
Okay,
So-
guys.
So
Yes.
far, send in our lab reports before then.
Correct. If y'all can do that so that she can go ahead and add it in, and you can have a more accurate input of what your grade is.
Okay. Is there like
Okay.
a certain day this week that you would like us to do that before?
If you can do
Midnight.
it by Saturday, that's great. But if you, the Unit 6 lab report technically isn't due until Monday, so if you want to wait till Monday, that's fine, and I can email and update it later.
Okay.
If you want to
So
get it in sooner.
so Sunday we'll have the updated one if we do it before then.
Yes,
Okay.
I'll bring it on Monday.
Okay. Thank you.
Okay,
if-
guys. Mhm.
I say- and it won't be on there if you send it after Sunday. If you send it after Sunday, I'll get it later that week. But if you want a current updated progress report on Monday, everything has to be in Saturday night.
Okie doke. Y'all have a good night.
Good night.
Thank y'all.
Thank you.
Good
for your
night.
time.
Thank you.
Yes. Okay, let's see how to